Okay, welcome back. Happy Friday. Today, we're going to talk about applications of systems. You can see we have 2 consecutive days on applications of systems. So just a quick review. On Monday this week, we solved systems graphically. That meant graphing 2 lines and looking for what? The intersection point, right? That was our solution. But graphical methods have a weakness. Number one, they're kind of time consuming, but more importantly, number two, they're estimates, right? And if your lines aren't exactly perfect, then you're not going to have a great estimate for the solution, the answer. So then last class, we talked about using algebra to solve the same kinds of problems, but it didn't rely on graphing. We had 2 different methods. One of them was substitution. Solve one equation for one letter and substitute into the other equation. And then the other method was this elimination or the add subtract method, where you make it so that if you just add your 2 equations, either the x's disappear or the y's disappear. And sometimes you have to do some work to get that to happen. So now that we know how to solve systems of equations, we're going to tackle a bunch of word problems. Today, the word problems will be a little bit easier than the ones on Monday. And looking ahead to next week, Wednesday next week is the review for our first test, which is Friday. So 1 week from today is our first test. Okay? Any questions on the calendar? Irene? So the test is, it's not really going to be much longer in terms of time, but it's going to be on more material. The quests have only been on, like 4 or 5 classes worth of stuff, but the test is on everything we've done this semester. Yeah, and the questions aren't supposed to be harder, it's just on more stuff. Yeah, which means that, with this thing just a week away, it's, again, not too early to begin studying for that thing. Don't wait until Thursday night next week to review the entire semester. Other questions on the calendar? Yes, so you can bring in a reference sheet of your own creation, and it's not too early to start making that. Other questions? Okay, good questions. All right, so top of page 83, and let's go here to the daily summary. Irene. Daily summary, please. Okay, so those are the 2 kinds of problems we're going to tackle today. Kayla, number 1. Okay, so we're going to merge a certain amount of the cheaper candy and a certain amount of the expensive candy to make 5 pounds altogether that are worth $17.60. All right? What if you did 5 pounds of the expensive candy, just all expensive candy? How much would 5 pounds of that expensive candy be worth? 20 bucks, right? 5 pounds times $4 a pound? Yes? Okay, what if instead we made the entire 5 pounds out of the cheaper candy at $2.50 a pound? How much would 5 pounds of that be worth? $10. No. 5 times 250. Close. I think it's 1250. 1250, right? Okay, so we know that if we used all the cheap stuff, then we've got a 5 pound bag of candy worth $12.50. But if we used all expensive stuff, that 5 pound bag of candy is worth $20. Would you buy that we can make a 5 pound bag of candy that's worth any number, any dollar amount between the $12.50 on the low end and the 20 bucks on the high end? It's just a matter of mixing the right amount of each one. So $17.60 seems reasonable. We just have to figure out how much of each to mix. Maybe it's 1 pound of the cheap stuff and 4 pounds of the expensive stuff, or some other combination, okay? I also want to point out at this moment that when we said 5 pounds of the expensive candy, what calculation did we do to find the value of that bag? We multiplied the 5 pounds of candy times the $4 per pound, yes? That was a very natural thing to do, was multiply the amount of candy by the cost per pound. Keep that in mind. Okay, step A, define your variables, including units. So here we are. C is going to be the number of pounds of the cheaper candy. Notice that there is a quantity word in there, right? Number of pounds of the cheaper candy. And then E is the number of pounds of the expensive candy. So we've got this table. And the table is filled in, but let's just make sure we're clear on why everything is where it is. So this one says number of items. That's just kind of a generic term, but really in this case it's number of pounds. So how many pounds of the cheap stuff did we have? Well, that's exactly what we called C, right? C pounds of the cheap stuff. And the number of pounds of the expensive candy we called E. And then this bottom row is real important. It's the total. Why is there a 5 down there? Total number of items, total number of pounds in our desired mixture, right? We were trying to get the 5 pounds all together. So 5 pounds at the bottom. Okay, then we've got the cost per item, or cost per pound in this case. And the cheap stuff is $2.50 a pound, and the expensive stuff is $4 a pound. That column is usually the easiest to fill in. And then we get to the last column, which is the total value. Now again, if I said we're doing all expensive stuff, all 5 pounds, what do we do? Find the value of that 5 pound bag. Multiply the 5 pounds of expensive candy times the $4 per pound, right? But we don't have 5 pounds of expensive candy. We have E pounds of expensive candy. So we're going to multiply the E times the $4 per pound. And that's what it says right there. 4 times E. It's like the 4 times 5, right? So 4E is the value of the expensive part of this bag of candy. And 250 times C is the value of the cheaper part of this candy. And there's this little note here, underlined. It says the last column is created by multiplying together the first 2 columns. And this is pretty common. Multiply this by this, and we stick it over here. I don't want you to memorize it. I want you to feel. It's like, okay, 5 pounds of expensive candy, 5 pounds times $4 a pound. That was natural. That's what we did without thinking about any symbols. Okay, and then finally the bottom right. What's this 1760? That's the total value. It's the desired value. It's in that bottom total row, right? And then we have to translate all that info in the table into some equations. The equations oftentimes come from different columns. So we know we have 5 pounds total. So if you have C pounds of the cheap stuff plus E pounds of the expensive stuff, it should equal the 5 altogether, right? And so that's right here. And then on the right-hand column, we have all of this. We have the value of the cheap stuff plus the value of the expensive stuff. Well, it's supposed to be worth $17.60 when all is said and done. So that translates right to here. 250C plus 4E equals 17.6. Questions on the 2 columns? Okay, so this is now a familiar looking setup. It's got C's and E's instead of the normal X's and Y's, but you can solve it either by doing the substitution method or the elimination method. You'll have plenty of practice doing that in the activity, but during the demo, I don't want us to spend time doing that old skill. I just want us to think about the setup. So I'm done with this problem for right now. You can check out this problem later. I put the answer there, so we should verify that you can get the answer. But again, I just want to focus on the setup for today. Okay, moving on to number 2. Let's go to Marcy. Okay, thank you. All right, let's see if we can buy that. So suppose that you have $100 and you invested at 8% interest for 1 year. How much interest will you gain in that 1 year? $8. Yes? It's just 8% of 100. And how do you find 8% of 100? Well, 100 is a real easy number to do, but if it were harder numbers, what would you do with the 100 and the 8%? I'd multiply, right? The 100 by the 0.08. And Ben is pointing out this important thing that percentages need to be converted to decimals when we do that multiplication. So multiplying 100 by 0.08 is a real natural thing to do to calculate the amount you get in interest, and that's exactly P times R. Principal is $100, R is the 8% written as a decimal. Okay, great. So let's try number 3 here. Alex. Okay, so lots going on in this problem. Let's start by defining variables. In order to figure out what the variables are supposed to be, go to the very end of the problem, which is the question. How much did he invest at each rate? Those are your two variables. So how much he invested at the one rate, I'm calling L for the amount invested at the lower rate in dollars, right? That's the unit. And then H is the amount we invest at the higher rate. But again, there's a big hint for all of these problems for what your variables should represent. It's in the question, which is usually the very last part of the paragraph. Okay, so then we've got this table. And again, this one is kind of friendly in that the table headings are all given. But we've got amount of money invested at the low rate, and that's just what we called L. And then the amount invested at the high rate is what we called H. And here we're going to put in the middle column the interest rate. That's easy. It's 4% and 9%. Again, it's been suggested as decimals, 0.04 and 0.09. And then what's going on here? What is this? It says amount of interest income is 0.04L. What we decided was that the interest is the principal times the rate. Yeah? We're just going to multiply the principal times the rate, the amount you invest times the interest rate. Well, the amount you invest is that column, and the interest rate is that column. So if we multiply them together, we're going to find the amount that you actually get in interest, right? The dollar amount. And so multiplying 0.04 times L tells you how much money you gained from that investment. Good? And the same kind of thing, 0.09 times H gives you the amount of interest income from the high rate investment. And again, how did we get this the last column based on the first two? We multiply them. Same pattern, right? The table headings are all different and the problem is completely different, but somehow the setup is essentially the same. You fill in the first two columns and you multiply them to get the last one. Okay, one other number here in the table, $2,000 is the total amount that we're investing, right? And so I feel like there's an equation to be had right there. What's the equation from that column? L plus H is 2,000. All right, so this is written on the next page, but don't look. Let's just see if we can figure it out here. L plus H is 2,000. Now the other sentence, the other equation isn't going to come from this because we're not told what the total amount of interest we got was. Like if I said it was $800 in interest that you earned, then the 800 would go there and it would really be like the candy problem. But the setup here is different, right? The problem here says his yearly income from the 9% is 37 more than the yearly income from the 4%. So we just have to translate that sentence into an equation. Let's give it a shot. The yearly income from the 9% is one of the entries in the table. Which one is it? Is the 0.09H. Buy it? That's how much money you got in interest from the 9% investment. So translating that circled phrase, we get 0.09H. Is a certain symbol in mathematics equals. $37 more than 37 plus. Yeah. So we're just translating phrase for phrase. That sentence is going to become an equation. Let's see what's left. The yearly income from the 4%. That's in the table. Which one is the yearly income from the 4%? It's the 0.04L. So there's the equation. Make sure you can translate that sentence into that equation. It's piece for piece. There's a lot of ways to get that equation wrong. But if you just go slowly like we did there, we just circled phrase for phrase, translated, you'll get it right. Okay, solving that system of equations, again, is not something we're going to do together. Just want you guys practicing in the activities. The answer is on the next page, so you can check it out later. One thing I'll suggest, though, is that last equation we just wrote becomes maybe a little more friendly if you multiply both sides by 100. Because if we multiply both sides by 100, then all those decimal points move 2 to the right. Yeah? And then we get rid of all of these decimal numbers. Not that you need to do that, but I'm just putting out there. If you have an equation with lots of decimals in it, multiply by 10 or 100 or 1,000, if you don't want to deal with those decimals. Okay, so moving on to the next page, that's the system we just wrote. There's a step-by-step process that you can read later on. This is for your reference. But what you're going to do now is move to the activity. So the activity has lots of word problems, 5 of them altogether. And then in the even more practice section, another 5. So altogether 10 word problems in the activity and the even more practice. You're going to be so sick of word problems by the end of today, but it's good for you. So push through. Raise a flag if I can.